All right, let's go ahead and talk a little bit about calculating volume. So volume is just the space contained in an object. So the first things that we should probably talk about are the formulas for different shapes. And our formulas here, the easiest type of formula to go over, first off, is just this standard box shape. So if we've got an object that just looks like a box, I will have a length, a width, and a height. And you're going to hear me say this a couple times. This type of shape is actually one of the easiest ones, and we call this a prism. What we're going to do is you can think of the area of just the base and multiply it by the height. And you're going to see this a couple places. But here, our volume for this is going to be that length times width, that's just the area of that base, times the height. Seems easy enough. But like I said, when we think about just taking any shape, like that's the area of that base, and then just multiply it by a height, well, that makes things pretty easy. So I could have what we call, we have a cylinder, which is just, in a lot of ways, it's just a circular prism. With that, I will have a radius and again a height. So the area of a circle is pi times the radius squared, and of course, multiply it by the height. Now we've got a couple other shapes though. And I'm going to start, and then we get into some of our variations or combinations with these. Two other shapes that we're going to go over are a sphere. So a sphere is just a, well, I hope you guys know what a sphere is. It's just a ball shape. And again, this will have a radius. The radius is just the point from the center to anywhere on the surface of that sphere. Now this one is a little bit different because it's not just a single thing up here. It would take me a long time to explain where this formula comes from, so I'll just give you what the formula is. The volume of a sphere is 4/3 times pi times the radius cubed. Our last kind of standard shape that we'll go over here is an upright cone. So this is a lot like the shape of your ice cream cone if it happened to fall on the ground. Here I've got a height and a radius. And this, since it's not straight up, I can't use the height the same way. But what I'm going to do, this is going to be, the volume of this is 1/3 times pi r squared h. So these are our formulas. Now, the things when you're calculating this, sometimes when it comes to these, sometimes you might be given instructions to do things like use 3.14 as a value for pi. For a lot of folks, if you have a calculator, you'll have a pi button, and that will give you many more decimal places. Generally more decimal places are fine, but if you're only, I'll say always follow your instructions. Okay, let's go over some questions like you might see. One, say we're trying to find a volume here, and we've got a figure like this. Again, this is just a standard box. I've got 10 meters times 14 meters times 3 meters. So that this formula is, our volume is our length times our width times our height. And looking at our units, just thinking about those units doesn't really matter. I usually don't include our units in these calculations, but I like to think about them. That's going to be meters times meters times meters, which is cubic meters, which is a unit of volume. Here, I've got my length times my width times my height. And if I'm doing my internal math right, that's going to be, I'm going to say that is 420. In this case, it would be cubic meters. And just to double check myself, because sometimes I do my own math wrong, 10 times 14 times 3. Sure enough, 420 cubic meters. I'm going to go over the fairly simple questions first. There are much more complicated shapes and combinations of shapes. So other things that you might run into are these things with maybe steps, and you can just break that up into a couple different boxes. All right. Let's take a look at, say, the volume of a cylinder. And this is obviously not to scale. I'm going to have some sort of upright cylinder here. Also, we've got a radius here of 3 feet and a height of 6 feet. And let's round to the 100th. So again, the area of that base is pi times our radius squared, and then times our height. And what we're going to do is we're going to plug this in, and our order of operations just follows us. So here, this is going to be pi times our radius, which is 3 squared, and then times our height, which is 6. So I'll deal with that exponent first, so that'll be pi times 9 times 6, and I can multiply those out. 9 times 6 is going to be 54, so I'll have pi times 54, and that's something that's easy enough to put into a calculator. And I'll show you that if we use 3.14 or the pi button, it will come out to be similar. They won't be the same. But let's say I've got pi times 54. And by the way, your calculator can handle it if you were to enter this in just like that. Okay, so here we've got an answer. This is with a more exact pi. This is going to be 169.6460033, and we can assume there's more over there. Rounding this to the 100th. I found my 100th place. I look one place over. This is going to be about 169.65. And guess what? That's feet squared times feet would be cubic feet. Oops. Now, if I were to use 3.14 there, it's going to come out to be pretty close. 3.14 times that to 54. In this case, it's 169.56. So it's pretty close. It varies past that decimal point. And usually if you're entering something into an answer blank, they will give you some leeway on some of those. So you have a little bit of stretch. Okay. Looking at something like a sphere, so with a sphere, we're going to use our formula for that. In this case, our volume is 4/3 times pi times our radius cubed. And again, rounding to the 100th is fairly standard. This time I will actually use 3.14 for pi. Pi is, by the way, the Greek letter P. It's the letter P in the Greek alphabet. Okay, this will be 4/3. Like I say, I'm going to use 3.14 here. So 3.14, and this is going to be times our 2 cubed. Now that's meters cubed. That would be meter times meter, which would be cubic meters. All right. And if I were to put this into a calculator, you could find that you could put this all into a calculator all at once, frequently. If you don't want to do that, I would say do this first, then multiply by that, then multiply by 4 and divide by 3. But most of your calculators could handle doing this just as is. Oops, sorry, that's 4/3. 4/3 times pi, which is here we're using 3.14. I'll just enter that in rather than use our pi button. And then times 2 to the 3rd power. So I can even put that in here. If you're doing this by hand, remember exponents come before multiplication and division. So that comes up with a big long decimal. This comes out to be, 33.49333 and change. Let's round that to our nearest 100th place. So this would be about 33.49 cubic meters. Let's see. I do. All right. And again, this is just doing our basic shapes. Here we've got an upright cone. And let's say I've got my radius is 1.5 meters and a height of 3.3 meters. Oh my gosh, I'm using decimals. Don't panic. Panic is not one of your steps. Here we know our volume is supposed to be 1/3 times pi r squared times our height. And the distance from the center of this circle to its circumference, that's going to be the radius. So I'm going to put in 1/3 times pi, and then I'll put in 1.5 squared. Our height is going to be that 3.3. And again, thinking about our units, meter times meter would be square meters, times another meter would be cubic meters. All right. And all we're going to do is we could just plug this into a calculator, or if I wanted to, I could do some of this by hand. But if you're doing that, remember, evaluate your exponents before you do any other multiplication. So if you wanted to do that, you could say, okay, 1/3 times pi, 1/5 times 1, or 1.5 times 1.5 would be 2.25. Times our 3.3. And again, if I were just plugging that into a calculator, 1/3 times pi, I'm going to use our pi value here. That's a bit more accurate than our 3.14. Times. Now, if you're entering this on a calculator, make sure that that exponent only is on that 1.5. So if I put that into a calculator, I would put that in here and then square it there. That way it's only squaring that 1.5 value and nothing else. Then times our 3.3. Okay, that's a much longer, it's a nice big long decimal. And that's about, well, 7.77544 and a lot of change. And in this case, it's going to be cubic meters. So this is going to be approximately 7.78 cubic meters. That, I find my rounding place, I look one place over, 5 or more, I add 1 to the rounding place. So these are our basic shapes. Beyond that, we can deal with some of our more, some different shapes or combination of shapes. And this is where things can get to be kind of fun. So say I've got, and I think folks have probably seen things that look like this before. Say I've got like a planetarium or a silo that's not that, you've got a cylinder. But instead of just having a flat top, it's got a hemisphere on top. Okay, well, our process is going to stay pretty much the same, but we're going to need to do a little bit of extra figuring. So this here is I'll figure out what to, so I've got this is like 5 yards, and our radius of this is 6 yards. So literally all I'm doing is I'm figuring out what the area of, what the volume of each of these shapes would be. So the volume of my cylinder is pretty easy. So my total volume is going to be the volume of my cylinder plus half of the volume of my sphere. Because this is half of a sphere. E-R-E, I can spell. Okay, well, here we go. Our the volume of a cylinder, that's our pi times our radius squared times our height. And that's going to be plus 1/2 of our 4/3 times pi times our radius cubed. And with that, I can just reduce those things. So this would be pi r squared h plus 2/3 pi r cubed. And with that, I can just plug in our pieces. So this is going to be what our volume is. So, and if it helps, we're probably going to come back and revisit this a couple times. So this might be a formula worth noting. But again, once you plug in the numbers, your order of operations takes over. So this would be pi. My radius is just the distance from the center to the outside of our silo. So that would be 6 squared times our height of 5, then plus 2/3 times pi. And again, if you think about this, this radius is going to be the same up here as it was down below. So our radius is still going to be 6 yards. So it'll be 6 cubed. If you want, you can calculate these individually and then add them together. I usually tell people to calculate first, round last. But again, if you are using a calculator, a lot of times you're going to be able to just put the entire expression in. And I like these style of calculators because you can actually scroll back and see what you entered in. So here I'm going to put this in as pi times 6 squared times 5. So this will be the volume of that cylinder. Now I'm going to add to that 2/3 times pi times 6 cubed, or 6 to the 3rd power. And I've got a fairly big number here. This is 1,017 0.87602. Most of the time you're going to get instructions to round to your hundredths place. So this would be close to 1,017 well, again, that's 5 or more, so this would be 0.88. And I'll have yards times yards times yards. So this is going to be cubic yards. So these are some of the types of questions that you're going to run into. Like I said, there's also some things that you might run into that are just a combination of things. And this would be a slightly weirder type shape. And if you're doing that, there's lots of different ways of breaking it apart. Say I've got like something that looks a little bit like a set of stairs. And then I could say, okay, well, once you figure out what each of these things are, we could break this up into 3 different boxes. So with that, I could break this up into, say, 1 box and 2 boxes and 3 boxes. So I could say box A plus box B plus box C. That would be relatively easy. If I were doing something like that, this would be some strategies to think about. And so, there's all different types of shapes that you're going to run into. But, I think that's long enough for us to talk.